So in this video, we're going to talk about latent heat and the specific latent heat of a substance. Now, we use these quantities, right, to study substances that undergo a change in state. So the specific latent heat of a substance, oops, I'm on eraser mode. The specific latent heat of a substance L is simply the amount of heat supplied or lost per unit mass of a substance that changes state. So we'll talk a bit about that, a little bit more if that sounds a bit confusing. And the latent heat, of course, big L, is just the amount of heat gained or lost to change the state of an entire substance or object. So let's study this simple idea of ice gaining heat. Now, when we involve solids to liquids or liquids to solids, we use something called the latent heat of fusion, usually denoted by LF. Okay, and so LF is basically Q over M, or in this case, the amount of heat required to melt or to freeze per unit mass of a certain substance. So just to put things into perspective, right, the latent heat of fusion of water, I believe, is about 330 kilojoules per kilogram. Okay, so in other words, to melt 1 kilogram of ice, you would need 330 kilojoules of heat. And to freeze 1 kilogram of water, you would need to lose 330 kilojoules of heat. And so let's look at another thing. If the change in state involves the gaseous state, then we use something called the latent heat of vaporization, or LF. And this is usually a lot larger than the LV. Latent heat of vaporization is usually a lot larger than the latent heat of fusion, right? And so, of course, if I have some steam that is going to come and hit the cool surface, you expect it to condense, right? And so that's a change in state from gas to liquid. And so we can say that the amount of heat lost over here is simply the latent heat of vaporization. Remember, this is per unit mass, and so we can multiply by the mass of steam that condenses, okay, to make this equation relevant. Of course, it can go the other way. If I boil water, then the heat is gained and not lost.